Okay, never mind. Now I record. 4.3, union and intersection of two different sets. Sometimes can be more. Okay, so union. I believe most of you understand the word union. It means a combination. So in this case, we use this symbol over here to represent union. What does it look like to you? The letter U. Okay, so the letter U, this symbol that looks like letter U is used to represent union. So A union B, the definition, A union B is still going to be a set. What is inside this set? Well, the elements inside this set will be elements of A or elements of B. As long as it's inside A or it's inside B, then it is an element inside A union B. Okay, this over here is a set. Okay, inside a Venn diagram, here I've got my universal set represented by this universal sign. And I've got set A on the left, set B on the right. Now, the shaded region in the Venn diagram represents A union B. Where's the shaded region? It is all this. Look at how I'm shading it. All these will be A union B. As long as it's found inside, it is A union B. Okay? Alright with this part? Need help, anybody? Together, everything. Okay, let's try this question. Is A union B the same as B union A? Are they the same? Yeah, they are the same. Because A union B, I get this. Then if I do B union A, it is the same thing. Okay, still shading the same part. Okay, the other two, you can go and think about it yourself. Let's try questions. Okay, I've got set A with the elements 1, 3, 4, 9, 11. Set B 9, 11, 13. Okay, look at these two elements, these two sets. Are there some elements that are common?
No. 11.
Hmm.
9, 11.
Any more? Any more? Any more? These two are common, right? Okay. Can I say that 9 and 11 are found both in A and B?
Yes.
Okay, very good. What about the element 1?
No.
Is it found in A?
No. Yes.
Yes, right? Is it found in B?
No.
Okay, the element 13.
No.
It's found in B, not found in A, right? So now, list the elements of A union B. A union B, again, it is a combination. Either found in A or found in B. Can be found in both at the same time. Okay, so mentally, this will give us 1, 3, what else? 4, 9, 11, 13. Okay, these are the elements. Yeah, union is just everything. Is A a proper subset of A union B? Okay, again, proper subset. First thing, must be a must be a subset. Be subset. Yes, number 2, cannot be equal. Okay, what does must be subset imply? All elements in A must be in, now no longer B, this time it is A union B. Okay, because they're asking whether A is a proper subset of A union B. So we ask ourselves, are all the elements of A found inside A union B?
Yes.
Yes, it is. Okay, so yes. First condition, met. Second condition, cannot be equal. Are they equal?
No.
Are they equal? No, they are not equal. Second condition met. Yes, so it is a proper subset. Yeah. Is it a proper subset? Answer is yes. Then explain your answer. Okay, this. Since every element in A is an element in A union B, that is the first condition, and they are not equal. How do we prove that they are not equal? We just find one element that is not found in A union, that is not found in A union B. Yeah, just prove that there is one element that is not found in other one. So they are no longer equal. Therefore, it is a proper subset. Easy? Okay, let's try to list down this. Let's just do it together. Doesn't take you long. C union D, what is it?
A, C,
We got C, E, U, D, K, Y. Do we need to write E double times? Do we need to write E 2 times? No, it is the same element. Okay, so is it a proper subset? Is D a proper subset of C union D? Yes or no?
Wait.
No.
Why not?
Because D got no A.
Because D got no A.
Oh wait.
Yes, what?
Yeah.
Everything is inside.
Yes, it is a proper subset, right? Everything inside D is found inside C union D. And D is not equal to C union D. Then you can give an example. For example, Y, element Y is not, element A is not found inside set D, but it is found inside C union D. Therefore, D is a proper subset. Anybody lost? Lost?
Wait,
Which
so-
part? Cannot be everything.
so if-
What do you mean Y1 is proper
so
subset?
like C,
Wait, let me answer one at a time. Jolene, what's your question? You don't understand which part? Huh? Can't hear you. Do you miss any lesson? Then okay, do you understand these two conditions? Do you understand this one? Okay. Then let's change it. They're asking whether D is a proper subset, right? So all elements of D in set D must be in C union D. Do you agree with this? Okay, the second condition is that C cannot be equal to C union D. Do you agree with this? The second condition? Okay, then let's verify. The first condition, all elements in set D must be in C union D. Okay, so this is my C union D. Are all the elements of D found inside here? Are they all found there? Yes, right? We've got E over here, we've got K, and we've got Y. Okay, first condition is met. So it is a subset. C is a subset of C union D. Okay, second condition. Second condition for it to be a proper subset, C cannot be the same as C union D. Otherwise, they'll be known as equal already lah. Right? So I cannot have them be equal. Let's see whether they are equal or not. So this, I'm going to highlight in yellow, C union D. Tell me whether it is the same as D. Are they the same? The green and the yellow parts? Not the same, right? Because one obviously has more than the other. So the second condition is also met. Oops. So now I have met two conditions required for proper subset. So okay now? Okay, next one. Francis, you had a question? Or have I answered your question? Or do you need more time to think about your question? C can also be a proper subset of C union D. You are right. Okay? Okay, Rhea? Oh, okay? Okay. Now, without looking at the answer, can you do this? Without looking at the answer? Do it mentally. Shade the region representing A union B complement. It's not A union B, it is A union B complement. Step 1. I want A union in the complement of B. So I will draw A union B. Oh, no. I will shade A. Okay, so this is what I'll do. I'll shade the entire A, including this part. No need to be afraid of shading into B. As long as it's inside A, I want to shade it. Okay, this is for A. Step 2. Shade B complement. But you either use a different color pen or you go the other direction. Okay, so complement of B. Do you know where is the complement of B? Do you know where's complement of B?
Yeah.
Outside B, right? Everything that is outside B. So I shade this way. Now, it's okay to eat into A because as long as it's not inside B, it's fine. So I must be very, very careful. Okay? Now I've got B complement. Since they want union, union means everything that is shaded. Okay? So, step 3. Union. I want everything that's shaded. So look at all the shaded parts. Whether it is one stroke, one direction, or the other direction, or both. I want everything that is shaded. So the final answer is actually all this. Okay, you get the idea? Ken? Any questions? Then your turn to try yourself. Shade the region of A complement union B. No, it's already in our textbook. Okay, I want A complement union B. I will draw as a working A and B. I will first draw. Actually, this one's straightforward enough. Okay, this one I'll shade A. I'll shade A complement. So everything that is outside of A, I will shade it. And this region over here, the center intersection part, is very, very important. You must show the marker that you are careful not to touch A, not to go inside A, but you have everything else outside. Okay, so this is A complement. Then now I have B. I require B. So I use the other direction to indicate inside B. Okay, so this is my working. This is for A complement union B. Then now my final answer, I will just use one direction to shade. I will shade everything that was shaded. And it includes this part.
So it doesn't include, right?
It does.
Like outside B, right?
But I want everything in B as well. Okay, so this is my final answer.
Then how come your right side shade?
This is your final answer, right, Cher?
This is my final answer.
Which one?
This one is my working.
That one.
Didn't you say one direction and another direction?
Hmm.
Then the other one, why all one direction?
Because this is the final answer. Final, when we ask you to shade something, you usually use one direction to shade only, right?
I didn't just. I did like that.
Huh? I can accept also lah. Okay, but I just prefer the final answer to be in one direction. If you give your answer like this, I'm also okay because it shows that it is shaded. Okay. Now, part B is A union complement B equals to A complement union B. Are they the same? Not the same. How will you explain? Isn't it shown here already? Right? In example 16, we've got A union B complement. In this one, we've got A complement union B. Look at the two of them. Are they the same? Are the shaded parts the same? No. Okay, so they are different. You can explain using a Venn diagram like this. You draw two different Venn diagrams and show that they are different. Okay, next part. Just as important to union is intersection. And this part is where some students can get confused between union and intersection. Union, one more time, includes everything that is shaded. Now, when we come to intersection, we use this symbol. It is like union, but it is upside down. Okay? In this Venn diagram, I've got A, I've got B. They intersect at this part. Do you agree? Only the center part is the intersection part. And this is what I'm interested in only for intersection. So look at the definition. when A intersects B, the elements must be inside A and, this is an important keyword, and inside set B as well at the same time, simultaneously. Okay? So it is only this small bit. Can see the difference between union and intersection? So which one is more stringent? Yeah, intersection. Okay, intersection is more stringent. It will result in a smaller pool of elements, whereas union includes many things. Okay, so let's look at an example. Set A, B, and set C. List the elements of A intersect B. So A intersect B, we've got, come, let's do it mentally. It is found inside set A and set B at the same time. They intersect. So what do we have? Oh God. What do you say? D? T. Any more? Any more? Is that all?
No. Yes. Come on.
Let's compare these two only. What are the common elements? T. Only T, isn't it? So that is the element found inside A intersect B. Okay, what about A intersect C? A and C. What do we have? Is that A?
No.
R? T? None of them are common, right? So I've got an empty set. What is this set called?
Empty set.
What is another name for this empty set? No. Remember this one? What is this not called? Starts with N. N-U-L-L. Now. N-U-L-L. Now.
这刀剑针，
Huh?
又来刀剑。
What talking? Okay, next one. B intersect C. Compare these two. What are the elements inside? Do it step by step, one by one. T. Is T common? No. I. Is it common? No. M? E? Okay, that's it. Okay, so here, now. Okay. Oh, what is this? A and C are disjoint set. A and C are disjoint set. What do you think they are trying to tell you?
They're not intersect.
Yeah, they absolutely do not intersect each other. This is A
So
and this is C.
So do we use the noun or the different?
Now, use now. This one. This is just a word to describe it. Okay? So if I ask you to draw a Venn diagram, right? Is it going to look like this? Okay, then where will you place B? Where will you place the set B? In the middle? You mean like this?
Oh. They're not. They're not.
Overlapping A and C like this?
They're not.
Is it?
Because B don't have A.
B do have A? What do you mean?
Have.
So is this correct? Yes, right? Can you, let's just list down for fun. What is inside A but it is not inside B?
B. Oh wait.
A but not inside B.
I.
A, what else? R. So what's found inside here? T. Sophia, okay? Okay, what is found inside B and C at the same time? B and C. M, E, right? Okay, what else is found inside C? O, D, Y. Any more? L. Anything I missed out? Where is I? Any more? That's already. Okay. What is inside A union B? List the elements. A union B. Are you sure everything?
Wait, A-R-T type. T.
So what are the elements? A-R-T, I, M, E. Okay, very good. What is found inside A union C? A-R?
A-R-T-M-E-L-O-D-Y.
Yes, correct. What is found inside A union B union C? Everything. Now it's everything. Okay?
Then you got the
Apostrophe. The complement. You want to try complement? What is found inside? This one. How about this?
Okay.
This one. Can do or not?
Why complement the whole
A.
Why cannot complement the whole thing? I can complement the whole thing, right?
So nothing right inside.
What, are you sure nothing?
Yeah, because you
Look carefully. Think carefully.
P and P that's it.
Look and think carefully. A union B, then I complement it.
Not if A or O here.
Yeah, Harif, you're correct. The rest, think. What is it?
Why O D L Y?
So what is it? A union B complement. So we do it step by step. What is inside A union B? A, R, T, I, M, and E, right? So if I want to complement this, I want to complement this, right? Which means I want everything that is not inside here. So what is not inside A union B? This is, I'm going to shade A union B now. This is A union B, correct? But I want complement of A union B. So I want everything that is outside A complement B. A union B. That will be L dy.
C is not inside.
Yeah, exactly. It is not inside. That's why I am having it as my answer. It is a complement. Okay? So your turn to try. This one's simple one. We can do it together. What is inside P intersect Q? P intersect Q.
5, 9.
Now set. So it's empty set. What is inside P intersect R? 6 and 8. Okay, what is inside Q intersect R? Okay, it's just identifying the numbers that are common. Yes? Go and watch the video. Go and watch the video. Huh? Go and watch the video, okay? You cannot, then you can't find me again. Okay, now, your turn. No, let's do this together. Shade a region representing A intersect B complement. A intersect B complement. Okay, so here we've got my working A and B. So A, I will shade A first in one direction. Now I want B complement. B complement will be everything that is outside B, isn't it? Shade the other direction. Be very careful that we don't intrude B. Okay? So now, I want the region of intersection. Intersection refers to found in both sets at the same time. Now look at the diagram that I've shaded. Which region is shaded twice?
A.
Huh? The entire A?
A and half A.
So when I say intersect, I mean it is shaded twice, right? So I will be looking at, because I chose to shade one direction, I chose to shade the other direction, right? I'm now looking for areas where they cross.
So A.
So exactly where do they cross? This is my working. This is my answer. It is over here. Am I right? Is this the part where they cross?
Yeah.
So do you see that if you leave this as your answer, if this is your answer, then you are shading a lot of things, right? So I'll take it that you are telling me this entire part is your answer, but it is not what you're referring to, isn't it? So that's why this is just the working. That's why your final answer is going to look like this. Okay. So part B, illustrate the elements of universal set A and B using the Venn diagram in A. So here we just put on all the numbers inside B part 1, and hence list the elements of A intersect with B complement. A intersect B complement is already shaded over here. This is A intersect B complement. Now I want the elements found inside A intersect B complement, meaning in this shaded region, I want the values over here only, the shaded part, which gives me only 1 and 3. Okay, imagine if you did not do the shading of the Venn diagram, it is very, very difficult to mentally identify that 1 and 3 are found inside A intersect B complement. Only because we shaded the correct portion, and then after that we place the numbers correctly, then I know which part I require, which is 1 and 3. Okay, so now you gotta try it 18 by yourself, and Francis, you gotta come over and illustrate, shade first. This is a very common type of question, common O-level question. But it won't be so easy lah. Okay. So in my working, A and B, I will shade complement of A. So be very careful. Especially this part, very important. Don't pretend, don't try to do it as though you are shading but not shading and then make me guess. Because I always will guess wrongly. Because I know the answer, I'll just guess it wrongly for you. Okay, so this is complement of A, and I require B. So in the other direction. Since I want the intersection, I want to find all the crosses. So see inside here, we've got all the little crosses. This is my required portion. So this is my answer. Okay? So now illustrate the elements using the Venn diagram. Inside A and inside B at the same time, we've got A. What else do we have? S. Okay. S and T, right? Anything else? Okay, so inside B it must be E, and inside A we've got R. That's all. M. And inside the universal set, A. So just put it anywhere else lah. K. Oh no, A, yeah. K. Anything else? Do I have everything already? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, correct. So you can check like this. Count the total number of elements, make sure you didn't miss anything out. Hence, list the elements of complement of A intersect B. That is going to be, what is the answer? Complement of A intersect B, what is your answer? E. Only E. Can? So is A intersect B equals to A intersect, A complement intersect B the same as A intersect B complement? Okay, answer is no. They are not the same. We can use two different Venn diagrams to show us. One is this is A intersect B complement. This is A complement intersect B. So the other one looks like this. A and B. This is A intersect B complement. So we see that they are different. Then you can also list elements to say that, this element is found inside this set, but it's not found inside that set, that's why they are not the same. Okay, so example 19 over here, we are working in numbers again. Sometimes students get intimidated when they see numbers, but it's the same concept. In the universal set, inside my universe, x is a positive integer. to help you visualize, this will be 1, 2, 3, so on and so forth. Positive integers. P is a multiple of 3, so we've got 3, 6, 3, 6, 9, so on and so forth. And inside Q, we've got 5, 10, 15, and so on. Represent them by listing elements. Okay, done that already. Find P union Q. Okay, P union Q. How do we list down, or how do we describe P union Q?
Everything.
Everything, right? So I'm going to require 3. I need 5. I need 6, 9, 10, 15. So can you give me a description for P union Q? Like I said, P is a multiple of 3, right? I say Q is multiple of 5.
All multiples of 5 and 3.
All multiples of 5 and all multiples of 3. So
If they put like multiples of 5, multiples of 3, don't need to state everything out.
no need, no need. So in this case, in B, they want a union, right? You can write it out in words. X. The elements are X, where X is a multiple of 3 or X is a multiple of 5. I think just now when you said the answer, you said a multiple of 3 and multiple of 5. Okay. Let us compare it with this. We're going to write above it, X is multiple of 3 and X is a multiple of 5. Okay, is there a difference between these two? Yellow and green. Is there a difference? What is the difference?
Or
Or N. Is it a significant difference?
N is less equal.
Okay, which one is more stringent?
Or
Which one is
you don't know the difference.
let me change the word. Let me change my question. Let me rephrase it. You can tell that there's the difference between the word and or in these two cases, right? One sentence refers to intersection. The other sentence refers to union. Which one is which one? Union is? Okay, one more time. One of it is union, the other is intersection. Which one is which one? Okay. Yellow is? Yellow is intersection. Are you all okay with that?
So N is
This is intersection. Then the green one?
or is union.
Union. Is this important? Is this an important difference? Yes, it is very important. And sometimes the question, they will use words like this, and, or, and you are supposed to be able to interpret it. Okay, so be very careful of what you use. So now, P intersect Q. Intersect, look at what they have over here, N. So, X is a multiple of 3, and it is a multiple of 5. What is a multiple of 3 and a multiple of 5 at the same time? Something that is a multiple of 3 and a multiple of 5 at the same time. How can you describe this number to me? It's a multiple of 15. See? Multiple of 3, multiple of 5, multiple of 3, multiple of 5. These are all multiples of
15 and 3 N.
So instead of writing it is a multiple of 3 and it's a multiple of 5, you can write it is a multiple of 15. Because that's how multiples and factors work. Okay, as shown over here. Okay, so try 19 now. Okay, so represent them by listing the elements. First one, universal set, we've got 1, 2, 3, so on and so forth. And we've got 2, 4, 6. Multiple of 7, 7, 14, 21, dot, 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 close the brackets. M union N. So X, where X is is a even number. M union N. Even number. Anything else? Or, okay, or multiple of 7. Okay, next M intersects N, X, where X is a multiple of 14. Because multiple of 2 and multiple of 7 must be multiple of 14. If you wrote it this way, X is a multiple of 2, or 7.
Actually, X is even number.
Okay, and even number, right? So like this, it will be correct. But let me try listing down what we have over here. I've got 2, it's an N, right? So it must be, 14? Right? Next number will be 28, followed by 42. How do you know? You are correct, but how do you know? Times? No. What do you do from here to here? Plus 14. Aren't these all multiples of 14 then? Right? And we got it because they are multiples of 2 and multiples of 7 at the same time. Therefore, these are multiples of 14. X, where X is a multiple of 14. Okay, last example. X is an integer between -2 and 4. I prefer to just list them down since it is a small range. -2, -1, 0. Okay, got all this. And P, X, 3x minus 1 is less than 4. It is an inequality which I can very easily solve. Q is a quadratic equation which I can easily solve with factorization also. Okay, expressed in set notation, the set shaded in the Venn diagram. Now this is opposite. This usually you get questions shade. A, for example, complement, union, B. For example, now they shaded the parts for you. They ask you to describe it. So they are asking you to go from here to something like this. But you have to figure out what is it. What is the relationship? So if we do an easier one, can you describe the shaded set? How do you describe this shaded set? What is this called? No, it's simply B. This is set B, right? I shaded set B, isn't it? Okay. Can you describe this set? Okay, what is this set called? This is called B complement. Are you able to see that? Can you work backwards? This is B complement. Are you able to describe this? What is it? Is it bracket something complement? You're right. It is something like this. What is inside?
P, then
P, union, Q. Can you see that? Yeah, you are expected to be able to do this. Okay, this is the complement of P union Q. Okay, so find the elements of the shaded region in A. So all we need to do is to solve the inequality. Let us find out what is inside P. So inside P, you've got 3x minus 1 is less than 4. Sorry? Union. Okay, so back to part A. If I ask to check your work, I want you to shade P union Q. Then you will do this, right? P and Q, you will shade everything. Correct? So if I want to complement, then must be everything that is not shaded. And therefore I will get this. Okay? So this is P union Q complement. So back to part B of the question. I want to solve the inequality. So 3x is less than 5. X is less than 5 over 3. So the elements of the elements for P. We've got 1. Can I have 2? Oh no, I start from negative 2. Okay, negative 2, negative 1, 0, and 1. And I stop over here because 2 is greater than 5 over 3 already. Okay, so these are my elements inside P. Then I need to find my elements inside Q. To find the elements inside Q, I need to solve. X squared minus 3x minus 4 equals to 0. X minus 4. X plus 1 equals to 0. X equals to negative 1 or 4. Okay, so inside Q, I've got negative 1, I've got negative 4. So negative 1 is over here. I've got negative 2, 0, and 1. That is inside P. Agree this? Okay, then everything else must be found outside. So we've got 3, I've got 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So blah blah blah. What did they want? Inside the shaded region A. So 2 and 3 lah. So these are the two elements, not inside, as in these are the two elements that are in the shaded region. 2 and 3. Okay? Or this is another way for them to represent the shaded part. They call it complement P intersect complement Q. But you are absolutely right to call it P union Q and we intersect. These two are equivalent. Okay?